We're coming in hot. Thank you for joining us today for the OpenUSD Insiders live stream. Today is focused on our robotics office hours. My name is Edmar. I'm the Omniverse Community Manager. I'm joined by my excellent co-host here, Raffaello, tuning in from Italy. Hey, Raffaello.
Hello everybody. Buonasera from Europe's part of the world. Good
Amazing.
evening.
So glad to have you here. This is such an exciting episode. I really enjoyed the warm-up and looking at some of the materials we're going to be presenting today. We're going to be diving into Sonic. That is Supersizing Motion Tracking for Natural Humanoid Whole-Body Control. This is a new framework out of NVIDIA Research that tackles one of the biggest challenges in humanoid robotics, and that's getting a robot to actually move like a human and not just walk, but crawl, manipulate objects, respond to teleoperation, all from a single unified policy. This is very exciting because we're going to be actually doing a walkthrough and even showing a quick start. But generally, and we're going to dive into the details in just a moment with our special guest, which we'll introduce. But Sonic is using a large-scale human motion data combined with reinforcement learning in Isaac Lab to train whole body control. The result is a natural, versatile humanoid behavior across locomotion, manipulation, and multimodal tasks. Our presenting guests that you can see on the screen right now from NVIDIA are Jan, we have Jung Yi, and we have Shenron. They're going to walk us through the research, the architecture, and a quick start demo. Raphael is going to be a big help to this live stream, helping to moderate some of the questions, which we absolutely encourage throughout the live stream. But here's the thing. Try to keep your question on topic to what we're talking about, and then we're much more likely to be able to talk about it on the air during this live stream. Otherwise, we're going to point you over to some other official resources we have on other topics. Okay, let's get into it, actually. So why don't we go around and let's introduce everybody. So Raffaello, people probably know you already, but what is your role at NVIDIA? And we'll go down the list here.
Well, Edmar, yes, good way. And say hi, everybody. I'm technical marketing engineer in NVIDIA. Now 5 years that I work in NVIDIA, a long time. I don't know, many people know me from NVIDIA or before. I follow all events related for robotics, ROS, all other events around the world. I live in the UK, all events related to the UK, and all stuff related for robotics, from physical AI and everything related for robotics.
I'm so happy to have you here. It's always very helpful to the community.
Thank you, Edmar. I'm always super happy to stay here, and I hope to see you soon, maybe for the next GTC.
It will happen. I think we actually are at NVIDIA the same amount of time. I'm here 5 years also. We're 5 years.
Oh, wow! When we celebrate.
Jung Yi, very happy to have you join us. Why don't you share a little insight on your background and your role here at NVIDIA?
Yeah, thank you, Edmund. Yeah, my name is Zheng Yi. You can call me Zen. I'm a new NVIDIAN. I joined last year, and I'm a research scientist at the NVIDIA Gear Lab. We're a research lab doing humanoid research and humanoid and robotics. We aim to build generalist agents for robotics in the future. And yeah, I focus on whole body control and whole body local manipulation for humanoids.
Amazing. Well, thank you so much for joining us today. And we have our other colleague, Shenron.
Hello, everyone. My name is Shenron Li. Now I'm working in the Isaac application team, specifically Isaac local manipulation. I'm also working on the whole body control of the humanoids and doing reinforcement learning stuff. And yeah, I'm also very new to NVIDIA. I just joined last year. Yeah.
Well, very happy to have you. And of course, last but absolutely not least, Jan, thank you so much for joining us. It's so great to have you here. Want to introduce yourself to everybody?
Hello, everyone. Nice to meet you all again. And also, I'm Yan. I'm currently the principal engineer and senior engineering manager at NVIDIA, building the robot learning technologies together with all the amazing colleagues at NVIDIA. Great to be here today to discuss about technology.
I'm very excited. This is going to be a really a nonstop action hour. Why don't we kick things off? I'm showing right now the link to the GearSonic website. We'll put that link in the chat. But the link is fantastic. We're going to go through that page in a minute. But before we actually move on, Jan had provided a very nice video, about a minute long, And I'm going to play this. There's no audio, so we're going to talk through this video. And Jan, why don't you tell everybody kind of what we're looking at? Let me get it started here. Here we go.
Yes. Yeah, so here is showing our work on the sonic, which is essentially learned from human motions. We actually scale this work with several dimensions. The first dimension is very large scale human data, and also second scale is around the GPU hours we use for training this, which is around 21,000 hours for GPUs. And also we scale this work with larger models compared to the previous work related to whole body controller. So the generalist model what we are currently looking at is around 42 million parameters. And also what's important about this work is actually it enables multiple modality of the control of the robots. You can do that with VR, teleoperation. You can also control it with text, videos. You can do the video teleoperation, meaning that the robot will mimic the human behavior real time with camera streaming as well. And also we also connect that with GR00T foundation model so that with this whole body controller, you can also let robot to do the task of local manipulation, object manipulation autonomously as well. So all this work is built with the Isaac Lab and also by using Isaac Lab simulator and train that with large scale data there, we can achieve zero shot sim to real transfer for this robot's whole body control as well. And more importantly, and very exciting, is that we open source everything about this framework. So that including the deployment work and also the training code and also how you connect that for fine-tuning the GR00T model. And also very excitingly, we also get our partner company Bones that they release open source data set for this, including human original mocap data, plus our retarget data to the G1 unit tree humanoid as well. So with Auros, you are empowered to train your version of generalist whole body controller with Auros open sourced code, data, and framework. Yeah, so super excited to dive deeper with all you guys around this work together with our expert who are the lead authors for the Sonic work, Zhengyi and Chenren as well. Yeah, thanks.
Absolutely amazing. You said so many things in that introduction, and I was tempted to use the clapping and the cheer button we've got on StreamYard, but I'll try to keep it professional. But really, really amazing, and I think obviously there's a lot of excitement around this being open source and available to everybody. Again, I'm looking at the website now. I'll scroll down a little bit, the website is actually, I think, one of the nicest websites that we have. Most colorful and most interactive, most exciting, most interesting. Lots of great videos of the team showing some of the examples of different operations. Really amazing. Okay, so how would you like to start in terms of diving in deeper?
Yeah, so how about we start with Zhengyi diving deeper into the training part of it? How do we build this whole body controller?
Yes, absolutely. Thank you, Yan. I will share my screen.
And then while he's bringing that up, of course, again, we invite you to submit your questions in the live chat, and we will try to take them. We'll take different breaks. The more on target they are, the more likely we can take them. But feel free to let us know where you're watching from as well. It's always good to see. All right, and I think we can all see your screen now.
Yeah, okay, great. Thanks, everyone. So in the meantime, while you guys are looking at the stream, if you want to play around with a live demo of Gear Sonic, you can click on the live demo button, and then you should be able to see a live humanoid walking around, jumping around. You should be able to play around with the humanoid capabilities. You can even drag it and make the humanoid do things and generate motions, basically play around with the live view. Okay, I will walk you guys through of our open source code base. It's in GR00T Whole Body Control. It actually is a very stacked code base now, we have like three pipelines, including Sonic and Motion Breaks, which is our kinematic planner for Sonic. So I'll quickly walk you guys through what is included in this code base. So there's a lot of news. We are still the most recent update is around a couple of weeks ago. We just open sourced our teleoperation fine-tuning scripts, but this code base contains the entire Sonic operations. So that includes training Sonic, the base whole-body controller, the scaled-up whole-body controller. It contains training the kinematic motion planner. It contains the teleoperation data collection pipeline. It contains the GRUD fine-tuning scripts, and also contains an older version of our whole-body controller, which is called decoupled WBC. So kind of you guys can see there's a lot of content here, and I will quickly walk you guys through one by one. So we have pretty extensive document here. If we go to the docs, the team really spent a lot of time walking through every steps we need to build the Sonic workflow. We have a quick start, sim to sim. If you download the dataset, git clone the dataset, and you have a reasonably powered desktop and then can run Mujuko simulation, we should be able to run this relatively quickly. We have a quick start guide. If you have Isaac Lab with a GPU equipped, you can download the checkpoint, and you should be able to see Sonic, our pre-trained checkpoint, and our sample data. You should be able to see the G1 humanoid running immediately. And we also have a sim-to-sim Mujuko guide where you can download the checkpoint and then install Mujuko and run and play motion with our Sonic framework, right in your local computer. And of course, if you want to play around with Sonic directly, you can directly go to the web demo, which everything runs in the browser. You can even do a little text to motion action, generate some motion for the humanoid to do.
That's wild. And Amelia is actually posting the link in the chat. I'm going to put it on the screen so people can see it. But there's a documentation page as well as the main website on the GitHub page. So we're posted both there in the chat. And let me know if anyone has trouble reading the screen. Yeah, I mean, if you can make it a little bigger, that would be great. I'm not sure.
Absolutely.
There you go. Yeah.
Yeah. And yeah, there is a lot of content here. If you have your own G1, I cannot wait for you guys to start trying install everything. It's for installing everything on your local machine, and on the Unitree G1 robot is going to be a little bit more involved into installing TensorRT, installing Jetpack, but we have provided very extensive documentation to walk you guys through. And if you guys have any problem, you can go to the GitHub issue page on our code base, and we will try our best to answer your questions.
That's great.
And yeah, I will quickly walk you guys through what's included here. We have VR teleoperation, we have teleoperation guides. We have a lot of tutorials running the motion tracking policy, running the kinematic planner with keyboard control, so you can kind of play around with your G1 with like a gaming character with our kinematic planner, and a lot more interfaces that are supported. You can stream your SMPL motion and your teleoperation motion, and last but not least, collecting data for your favorite VLA. We have like a whole entire workflow with Isaac GRUD M1.7, and then we have validated the entire workflow. We actually have community members already recreated the entire workflow and did some of the demo, and even better than us.
Wow, already? That's quick?
Already, yeah, very, very quick. And yeah, we have included our entire training guide for training Sonic. If you have GPUs lying around, you can train your own Sonic or fine-tune our existing checkpoint. As Yan have mentioned, we have open sourced our data. That includes the Bones Seed, a very large, probably the largest open source motion data set. And you can download it from Hugging Face, and you should be able to train and fine-tune your Sonic. At the same time, we do include ways to train on different embodiments. Here we included Unitree H2 as a reference workflow. but news will come out. We already have community members that have deployed Sonic on other robots, for example, the HAI bot X2, and we will start to support more and more robot natively as well. Yeah, I think that's pretty much about it. There's a lot more reference into how the deployment works and how the kinematic planner is trained, how to flash JPEGs. But if you guys have any questions, feel free to reach out to us. We also have like a community email that you can reach out to all the Sonic devs at I think it's gearsonic@nvidia.com. I will try to find the email later. But yeah, if you guys want to reach us, you can do email or on GitHub issues. And
wow, that's pretty awesome, actually. Very rare.
Impressive. Wow.
It's one of the things that I think the community has told us over and over again, and I'll share it with the presenters here, that we hear such great things about how accessible our developers make themselves to the community, and so that obviously monitoring the issues page and helping people there is fantastic, but providing an email, that's pretty amazing. So thanks for doing that. We'll post that in the chat also for any developers that want to dig in. That's very helpful then. Very the documentation seems very thorough.
We spent a lot of time.
I can tell. Okay, so
I'll pass to Tran.
Yeah, yes, great.
Oops. Hello. All right. Let me share my screen a little bit. Oops.
Okay, and I think we see it now.
All right, cool. Yeah. So thanks, Zhengyi, to introducing our documentation. Yes, we spent a lot of time to build this documentation to help people to understand how to run the stuff. So for now, I want to introduce more about our deployment stack, like how you can use it and why we have so many stuff there and how you can customize yourself with that. So in this page, this is called installation deployment. So you can find like where stuff is required for you to install everything on your side. So our deploy stack actually supporting you, like for example, you have your own laptop or some PC, you can install everything on your own PC, or you can install it directly on the robot's ORIN, so that you can run everything on board without any internet cable. So basically, the first thing I want to highlight is like using the TensorRT. So we require those versions specifically. So if you're using a different version, it will cause some problems. So please follow the guidance here. And if you click a link here, you can go to this TensorRT website, and you will find the required version. This one is for the if you want to use it on the desktop Ubuntu machine, and then this one here, this link will help. Sorry, this link will help you to have the TensorRT for onboard for the ORIN on the robot. So yep, after you have this TensorRTs, follow the steps here. Set up the environmental variable, and then get our repo, and then you can run. Let's see, yeah, run our scripts to help you install the system dependency, and then set up the environment parameters, and then you can run just the build. So then you will have the thing, ideally. So okay, cool. So for the models checkpoint is on this page, so you can follow the guidance here to download checkpoint. So for our released checkpoints, we have the Onyx model for our encoder and also our decoder. So in our encoder, we support like the G1 teleoperation, VR3 teleoperation, and also the SMPL. So there are 3 separate encoder. You can see it from our website's design page. Oh, this one. So yes, so this is our G1 encoder. This is our VR3 point encoder, and this is our SMPL encoder. So basically, there are 3 separate encoders that you can choose one to use. And in our repo, we already have a different input interface to help you to manage that. So yes, so let's go back to this stuff. So the release the Onyx already have every encoder there. So as long as you follow the way to use it. So let me quickly show you how to, for example, yeah, run everything. So maybe this page. Give me a second. All right. So let me quickly show you how you run everything on the robot with keyboard. We have a video to demonstrate like how you control the stuff. Okay. When like during this loading time, I
Loading.
give you a quick introduction about some other interface we have. For example, we have the keyboard interface where you're using the keyboard and you can try with our pre-built reference. You can also include in your own reference in G1 joints. And we also have the planner there with the keyboard, so you can click return on your keyboard, and then you switch the planner. It have different modes bundled in, so you can use your like a 1, 2, 3, 4, 5, the number out there to switch the different nodes, different mode. And also we have the gamepad interface. For example, you can use a Unitary official gamepad, and you can there's a key map there, and you can also do the similar things like a reference replaying and also the planner. But we also have the stream motion tracking. So basically, you can not only say, hey, I just use the controller here and the keyboard is our pre-built function. So you can also actually streaming the reference you want to track to the robot. So that, for example, you can use you can use the G1 format, in which you stream the G1's joints space to the robot. You can also use the SMPL format so that you can stream the human motion. You don't do the retargeting of the stuff. So those are served for like use cases. For example, you have another system there. You're already in G1. I think this video couldn't load a little bit, but maybe let me go through this motion tracking first later. Later we switch back to this keyboard keys. So in this stream motion tracking, we have different workflow, as I said. So first, you can try to stream with G1, in which you stream the joint pulse, joint velocity of the G1. So and our Codebase will automatically switch to this encoder mode 0, which is our G1 encoder to control the robot. You can also stream the joints plus SMPL combined, which is our currently televersion stack. So for example, you don't want we offer the Pico stack to help you to run that, but if you don't want to use Pico, you have your own way to generate SMPL estimation of the human. You can do in your own teleoperation, or for example, if you have some animation stack that already have the SMPL output, you can also you can connect it with our deployment with this protocol. For the G1 side, it's more like, for example, you have early works on the G1 already motion generation stuff. You can stream their motion through this, or if you would like to use your own retargeter, online retargeting stuff, or some pre-processed data, but you want to run it on different machine to stream to the robot, you can use this protocol. So we also offer the interface manager, so it will give you a way to switch different encoder during without like turn off the robot. For example, you can for this like a keyboard one, you can shift 1 to switch keyboard, shift 2 go to the gamepad, and shift 3 you will switch to the ZMQ manager, which is our motion streaming. So yeah, that's basically the thing we offer here. And another thing I want to also highlight is like we actually built the observation config system so that if you can actually reuse our stack to deploy your own policy. Basically, what you need to do is like you define your own observation functions, and also writing this observation config to tell the stack to say, hey, this is our observation. This is our policy observation, and it will read the observation in this order, and then send to your model automatically. So yeah, so this is very helpful if you want to try out different design of your policies observation, and also maybe want to have a different variant of Sonic with your own try. You just need to like editing this observation config with if you use our existing observation already, so you don't have to write any code, just write this config. But if you want to do some of your own customized observation, you just write a function, put it into our files, and give it a name. It can read. It can manage by this config. We already support a lot of. We already have some existing observation functions there, like the single frame motion joints, multi-frame motion joints, single frame velocity, multi-frames. Also have the orientation, Z observation, SMPL joint position, and other stuff. So yes, I guess that's about the deploy stack overview, I guess. So maybe, yeah. So happy to take more questions about those stuff. Please, send your question. If you have question during your using, you send it to the GitHub repo issue. We will look at it. If you have question online now, just ask us. I think we can save more time for the question space. Question phase.
Very cool. Very cool. Okay, so we've got. Oh, what happened here?
There are already many people that say congrats for your work. That is amazing. Sorry, but if I interrupt you, Edmar, but I see many congrats for your work.
Yes. Look at this too. I mean, I got to say, I'll put this on the screen. I don't have a robot personally, but the web demo is fun to play with. You're probably seeing a lot of people because that's really awesome to be able to fool around with it on the web. That's such a great feature. But we do have some more in-depth technical questions. So let's see if we can look at some of these that our producer Amelia has starred. This is coming in from LinkedIn. How stable is the movement on uneven terrain? This is coming from Thomas.
We have tested it on one of the demo. We've tested it on alone. So relatively stable. Obviously, Sonic is a blind tracker. So it doesn't have, if it is like stairs, you won't be able to handle it. But it is relatively stable. We have blooper reels where Sonic was walking on onto a curb. We're very surprised he was able to stabilize it and actually go down a curb. So yeah, it's relatively stable, but it's not. Don't quote me on that.
Okay. All right. Well, that's good. Good advice. Okay, this is coming in also from LinkedIn. This is Alexander asking, I've read about the port for AguBot X2. Any plans when to add multiple embodiments?
Yes, so we are actively working on it, mostly because some of the robots we have in-house, and we want to make sure that every single thing we open source, we have validated and tested on the bots. That's why we haven't done a lot on the AGI-Bot X2. But once we have validated it, if we have some robots that validate the workflow and then we make sure that the performance is up to our standard, we will add more and then open source them as well.
Okay, excellent. LinkedIn also, this is coming in from Farshad. Interesting work, congrats. Does the collected human data include force or tactile sensing, or is it purely position-based?
At the moment, it's purely position-based. It's a motion capture position-based, yeah.
Okay, great. Another one from LinkedIn. Wow, LinkedIn's a hotbed of comments, questions. This is coming from AJ. How will it react if it receives odd commands or a man charges against it?
Well, Chen here actually did a very interesting robustness test.
Oh, yeah.
Yeah, we actually try to push the robot, and also we use a very heavy stuff to push the robot. I would say the robot just pretty robust to that. It's just stably standing there. It doesn't do anything strange.
Okay, cool. I think I may have seen that video on the website too. Okay, we got it. This is coming from Omniverse ambassador Scott Dempsey, who's watching, who's over at Worker Labs, amazing company partner. Scott's asking, will Sonic be integrated with Komodo in the near future?
So actually, on the web demo, it's already integrated. If you click, if you see me, typing the jumping command, it will directly go to Komodo. Yeah, it's already integrated, and it's. If you clone the 2 repo and then throw your cloud agent at it, it's probably going to be very easy to pipe everything together.
Wow, that's great. Cool. That's good news for everybody there. Okay, this is coming in from X, from Shang Lu. Will it support dexterous hand manipulation?
It does. Right now, so Sonic is a whole body tracker. It provides whole body capabilities. So we actually do not care about what the end effector is. We have tried 3-finger hand. We have tried grippers, and if there is a dexterous hand that are within the load management of the G1, yes, it supports dexterous hand manipulation.
Fantastic. Okay, another comment coming in from LinkedIn. Awesome work. I'm wondering how much GPU time you spent on experiments from the initial idea to final result. That's a loaded question.
A lot.
A lot. I'm guessing
more GPUs.
Yeah.
A lot of it. Yeah, Sonic trains on 128 GPUs, and that's through scaling ladders, and we are continuing to scale our compute and our models as well. So I think the best answer is a lot, and you have to search through parameters. So a lot, 5 more,
and still evolving. And this is coming in from Thomas on LinkedIn. What's typical latency of the tracker with a default observation config?
Yes, with the default SMPL motion tracker, motion encoder, the controller natively, we have 10 frames and at the 0.02 second each. So that's about 0.2 second on the controller natively. That is for making sure that the policy has like a look ahead window of what is going to happen. And if you add up onto the operations time, add on to the Wi-Fi delay is actually a huge part of it. I think add up to about half a second to 0.4, 0.3 seconds on good network conditions. And that can be optimized. And then we are actively working on getting faster policies and lower latency. But that's what we are noticing is the policy does degrade a little bit because you're giving the policy less and less look ahead.
Okay, that's super helpful. Okay, well, thanks for that comment and question, Thomas. Well, Scott is very excited about hearing about the support for Komodo, so that's great. Wow. Let me see. This is actually more of just a comment. I'll put it on the screen. Very interesting work. For long-term deployment and future secondary market trust, one key question will be how motion control data, sensor inputs, and operational history can remain interpretable beyond the first owner. Verified deployment evidence, one-time condition, and documented control system behavior could become important trust signals for human robots over their life cycle. Thanks for that comment. Okay, this is coming in from X, from Aryan. Can Sonic 64D universal token be predicted by other models along with Cosmos also, like maybe Pi 0.7?
Of course. We use Groot because, well, we love Groot. But Sonic is the universal token. You can just collect the data and then train your favorite VOA with it.
Okay, that's great. Well, thank you for that one. Another comment coming in from LinkedIn. This is exactly the kind of work that shows why human robotics will need structured trust signals over time. I'll leave that up on the screen for everybody if they want to read. But thank you for submitting. It's great comments and questions coming in. And I wanted to share this on the screen also because I think this is pretty valuable background for everybody to take in. This is also on the GearSonic GitHub page for NV Labs. We'll post a link again in the chat. By the way, if you happen to tune in after we started the live stream, this live stream is available on YouTube right away, so you can watch in the beginning, and it will remain there. So feel free to share it also. And if this kind of content on the Robotics Office Hours is helpful, it would be very helpful if you give a like on the video. That kind of gives us a good indicator of the kind of information that is very helpful for developers. And of course, it would be amazing if you subscribe. That's also super helpful, not only for us, but also to help others discover the content we're producing. And then we can all help each other more. That's the great thing about community. Okay, that's great. I think we've answered the main questions that we had in the chat. If anyone else watching has a burning question for the team here, absolutely, you're welcome to post it in live chat. We'll try to bring it up. I think I saw it. Jan, did you have a suggestion earlier? I saw in our little background chat here. Did you want to go into a little bit deeper into the Isaac Lab training side of things? I think your microphone's muted right now.
Yes, we can potentially go deeper into this architecture and how we train it. Maybe Zhengyi, would you like to go deeper into this diagram?
Yeah, for sure. Yeah, I can walk you guys through. Let me share my screen.
That's great. While he's sharing his screen, lot of excitement here. Can we find the Sonic team at Iker 2026? Would love meeting the amazing team. Are you guys going to be there? I know we'll be there. NVIDIA will definitely have a presence there. I'm not sure if anyone from your team is attending. Do you know yet?
I believe some of our team members will be
Okay.
there, and also some gear team members will also be there.
Amazing.
Yeah.
Ariane, why don't you do this? If you want to follow up with me, I can maybe I can try to connect you to some of our developers who will be there. So shoot me a note on LinkedIn. Anyone can reach me on LinkedIn very easily. Just go to edmar.net and it'll go right to my LinkedIn page and shoot me a message there. Okay, fantastic.
Yeah.
And I think, oh, go ahead.
Yeah, actually today, the NVIDIA Robotics linking page just posted the whole list of ICRA paper that submitted by NVIDIA this year. So you can check out all our
Amazing.
research that will be presented at ICRA there.
Great. And I actually have a slide after we're finished. I'll go through some new slides, including on that conference and also GTC Taipei. So stay tuned till the end to get those announcements and news. Okay, I think we're looking at your screen now.
Okay, sounds good. I'll walk you guys through kind of one of the main idea of Sonic is multi-modal input. So different types of input needs to be supported by our controller such that we can make use of motion tracking. Motion tracking is wonderful. You can feed reference motion, but it is also kind of too flexible. You can basically fit anything for your robots to move around. So in order to make it practical and useful, we designed this multi-encoder pipeline where we can use different type of input. For example, the robot motion. This is every joint on a robot. We also have like a hybrid encoder where the upper body is sparse input and lower body is robot leg. And the last one is human motion, because all of the robot motion we use is translated from the human motion. So there is a rough one-to-one mapping from human motion to the humanoid motion. So that kind of get our gears turning, and we're like, okay, if there's one-to-one mapping, the neural network should be able to figure it out. So that's basically our idea, is like we directly feed the human motion and quantize into the same token latent space for the humanoid to perform. And the great thing about this human motion encoder is now for teleoperation, we can just directly estimate the human motion, and the humanoid controller should be able to directly grab that information and feed that to the controller and be able to move. So you don't need like a neural retargeter or translator to translate between the human motion to the humanoid. And that basically makes the workflow so much more easier, and you don't have to have like a delay, the retargeter, which will introduce delay into it, and then you can directly use the human motion. Yeah, and with these three different encoders, we basically support, I think, exhausted the list of your favorite ways of controlling humanoids. Since we have a kinematic planner that can generate kinematic motion based on an interactive gamepad control, you can just use a gamepad to control your humanoid, like I mentioned, and you can also play around with it in our quick start guide. If you have the planner, you can control your humanoid like a gaming character.
Wow.
You also have two ways of teleoperating. For example, if you just want to teleoperate the upper body and the lower body, I don't want to control it. You can just use joystick to control the lower body, and the upper body will use this VR sparse input, and that's a hybrid encoder. So that's kind of like a mobile manipulator mode where you'll use our interactive gaming kinematic planner for the lower body, and upper body is from the VR.
Okay, I think you just answered a question. Sorry to interrupt. I just wanted to say you just answered a question that was in the chat just now, how the whole body teleop will work. So the foot part would be the controller, the game controller?
Yes.
Okay, great.
Yeah, so the lower body will be generated by the interactive gamepad, and the upper body is going to be from the upper body is going to be from the VR headset. So it's like a hybrid. We call it a hybrid encoder. And then the whole body teleoperation. The whole body teleoperation is very especially exciting because that unlocks, I think, the full potential of the humanoid. You kind of see it from some of the demos we have here. For example, this guy right here is full body teleoperation. That is you are using both your legs and feet, and to kind of showcase the full power of the biped embodiment. And you kind of see this demo. This is completely autonomous, and this actually finished the entire task with relatively high success rate. It will pick up the trash and then open the trash can and throw it in. And this is completely autonomous, trained with GR00T and 1.7, and enabled only by our whole body teleoperation capability. And last but not least, since you can generate human motion, for example, if you have a key motion generator or you have some other text to motion generator, you can directly connect to the Sonic SMPL encoder, and then voila, you'll be able to have multi-modal control on your favorite humanoid. Yeah, I think that's basically our pipeline. And next up, I could walk you guys through on some of the detailed training pipelines if there are more questions. I can also answer questions if there are more questions.
I think that'd be amazing to walk through. We do have one question here we can start with, just about asking about other robots, but I think we covered this a little earlier though. But if you want to clarify this for this person might have tuned in a little late.
Sorry, what was the question?
Will it support other robots?
Oh yeah. We are in the process of working on more robot supports.
Awesome. Okay.
So and also we released the data set. So actually, with our training stack, and for example, you use the Bones data set and do your own retargeting, you can train the other robots policy with our training stack. Yeah.
Amazing. And actually, so any news and updates, this actually will be on this page, right? As we add more features, functionality, or support.
Yeah.
Perfect. Okay. Great. Really nicely organized information. Yeah. So if you do want to go deeper, feel free.
Yeah, absolutely. So to train Sonic, you first need motion data sets. We have this Bones seed data set that contains about half of our entire training data set. It basically has a couple hundred hours worth of motion data in there. You can request access here, and you should be able to download it. And then we provide training scripts to process the motion data set. Also, if you do want to, for example, train your own new embodiment, you could use something called Soma retargeter. To retarget from the Soma human motion. The Bones seed uses this format called Soma, and then you can basically use retarget Bones seed to your favorite humanoid using this retargeter. It's completely open source. I already see a lot of great work on retargeting using this retargeter to other humanoids as well. We are also internally working on supporting more humanoids using this retargeter. And once you have your data set retargeted, so the first step is convert motion, and then this is actually a very important part. Since in the Bones seed data set, we included a lot more than what we needed for training Sonic, and there's a lot of motions that are not necessarily suited for flat terrain motion tracking. For example, there's like walking on stairs, there's like sitting in chairs, and mostly for Sonic, we're doing flat terrain motion tracking. So you do need to filter out the reference motion with a bunch of keywords. This is quite important. I think we have community members where they have trained on the Sonic unfiltered data set, and they ask me, "Hey Zen, what's going on? This word is not as good as you guys showed," and basically they missed the filter motion step. And after you filter the motion, you will have the filter motion. You should be able to train with the script. We provide both the motion data set and the paired SMPL motion. This is on Hugging Face as well. And it's relatively easy to start training Sonic once you have all the environment set up. And it's relatively easy to train. To train Sonic, and we have the Sonic release checkpoint configuration, which uses it has 3 encoders: SMPL, teleoperate, and hybrid. This is the single node, single GPU training. And if we use accelerate run, we can use accelerate launch. We can use multi GPU and multi node training based on your favorite cluster. And it has the width and bias logging, of course. And if you want to debug it, you can run it with a smaller number of environments locally. And while you're training, you should be able to see the logs of the reward, the FPS, the episode length, and then the script will handle all the checkpointing for you. And if you want to evaluate checkpoints, we provide another script called eval agent TRL that can run either visualization or the evaluation on the entire data set to compute metrics such as success rates and PJPE and render output. If you want to train your job, you can also set up a job to evaluate your checkpoint together while you're training as well. That's what we do internally. Yeah, and once you have trained your Sonic checkpoint, within eval agent TRL, we have a way to convert it to Onyx for C++ deployment, like Trina mentioned. And after you have exported a checkpoint, you should be able to use it on the real robots. And since we have another Soma humanoid format, we also provide a 4-encoder setup where you can train with the Soma encoder in there as well, and it performs relatively similar to with the 3-encoder. Yep, and like I mentioned, we have the Sonic bone seat training data details here, as well as training on new embodiments. There is only a few number of files you need to change, robot configuration files, and then orders for converting from the Isaac order to Mujuko order and then vice versa. And you should be able to bring your new robot embodiment relatively easily. But obviously, the hard work is going to be on tuning the action scale, tuning the PD targets, and tuning the symptorial parameters for your specific and favorite robots. And that's about it for our training side. And I just want to mention one last thing. I tell everyone who teleoperate use Sonic, the Wi-Fi is the most important thing. Is the Wi-Fi delay. Buy your own Wi-Fi router. It's going to make your experience so much more smoother. Thank you very much.
Very cool. Well, great information. Great tip there. It's fantastic. We did see some more questions come in, so let me see if I can tackle some of these with you. Here's one. Our producer noted this in the private chat we've got. Great to see so much engagement on X. We love good questions coming in from there. Speaking of this one, are there plans for RTC support for training and inference, maybe in multitask DTI with flow matching objective, like implementation size 0 paper?
I see. I'm not sure what RTC is referring here, but yeah, we are training more sophisticated policies with perception loop. Stay tuned.
Okay, cool. Great to know. This is a question about another robot. I know we said we're still exploring and still working on that. We'll post updates, but just for visibility, this user is asking about UBTech robots, the Walker S2, for example. So we'll make a note of that so that there's one vote there, but also some nice, great congratulations and support from the community members. This is a great community member from LinkedIn. Amazing. Here's a great question coming in from YouTube. How long does it take to train? So and do you think I would be able to train on a single 4090? So it's more a question about maybe hardware and time.
Yeah, that is a great question. So what we find out during Sonic training and development is the longer you train, it gets better. And I think the best policy we left it training for like a whole week, sometimes even 2 weeks for some of our bigger model and longer training sessions. So it definitely does train longer, and then it does perform. We can see the success rate improves over time, and that's on 128 GPUs. I think for a single 4090, you should be able to train on like smaller data sets to verify. And for example, I would recommend training like on a subset of the bone seed data sets to verify your workflow. And it's always better, obviously, to have more compute. But I think for single GPUs, you can either train on a smaller data set or fine-tune our existing checkpoints on the motion that you care the most about. I think that would be the most fitting setting for a smaller number of compute, and it should still give you decent performance.
Oh, that's great.
Yeah, and also our community, some already try to use a single GPU to fine-tune the sonic checkpoint for their motions, and its performance pretty good. So yeah, if you are looking for get it to be more agile for your specific case, just try it out.
Okay, this one I'll definitely need your help with because I don't understand it completely. So maybe you guys do. Coming from YouTube, if it is too hard, then would fomenting be easier? Am I pronouncing that correctly? Is that a familiar term to you or no? Okay, me neither. Okay, good. It's not just me. All right, maybe clarify that question or comment in the chat, and we'll see if we can help. Okay, so let me see. Regarding the Wi-Fi comment or suggestion, so better use cable instead of Wi-Fi for teleop?
So we used Wi-Fi because we want the humanoid to be mobile, and which looks much nicer. Internally, we do use cables from time to time for some of the more prolonged teleoperation sessions. Yes.
Okay. And when you say Wi-Fi router, did you mean, because most people have one already, do you mean a dedicated one specifically for this? So it's not.
Oh, yeah. Dedicated one.
I see.
So it doesn't have other traffic.
I see. Okay.
Yeah.
That makes sense.
Don't
We have
use
the-
school Wi-Fi or corporate Wi-Fi. Those don't work. The delays is going to be off the chart.
Yeah.
Funny.
Yes. Yeah, my personally actually support using Wi-Fi more because it's you don't have cable on the robot, it's more safe. But yeah, if you found out your use case is super important to have low latency and other stuff, and you can also not really make your Wi-Fi be that speed that fast. Yeah, use cable for that cases.
Okay, that's good advice. And okay, so the YouTube question earlier that we couldn't figure out, he's laughing. He said he meant fine tuning. Is it too? If it's too hard, would fine tuning be easier?
Yes. Fine tuning would definitely be easier.
Okay. All right. Cool. Thank you for that. Good. Lots of great just accolades here. Let me see. Okay, this person just asked a general request. Can you please provide your point of view of this robot working in live stream? So that'd be fun. Duly noted. Maybe we'll see if we can get somebody that's you know who's really good at that? Shane Reitz on our team. He's been doing really cool stuff with the for the SO101 arm, for example. Okay, but very good. This person wants to clarify the Wi-Fi. Would 6 gigahertz? Is that would
you don't have to. I think I use 2.5. I tried 5. They all work as long as there's no huge interference. I actually just used for some of these demos. I just used one of like a small travel Wi-Fi box I bought on Amazon.
Okay, cool. And this person is saying it very clearly. Maria is on the money. Pure robotic Wi-Fi.
Yes.
Okay, very cool. And then let me see. Hey, this is a great member of the community. Actually, I got to hang out with at the last GTC in San Jose. Thanks for tuning in, Jeff. Here, he's just sharing a sample he's working on using my A1 planner my AI planner, sorry, for tasks to handle multiple usage. Keep working sonic policy, task execution, detect full bin, vision intercepts, and cues action 3, empty bin at dumpster, sonic policy, fluid navigation, dumping, 4, return to station, sonic policy, resume next task. There you go. Step by step. Very cool. Thanks for sharing that. Here's a nice question. Okay. Oh, go ahead, Jan.
Yeah, and also you can use Sonic with your agentic robotics workflow. Actually, some of our internal team already enabled that.
Very
Sonic
cool.
can do so many things. You can connect with the AI agent to make the whole workflow doing the different tasks for the robots.
Awesome. And that developer, Jeff, I know firsthand, he showed me a picture. He's got like multiple Sparks on his desk. So he's really going all in with the hardware. It's really, really cool setup. This question coming in from YouTube: how is Soma retargeted different from GMR repo? Because I think I saw that it was inspired from it.
Yeah, Soma retargeted is just another one, and used the Soma human format, and it supports other robots as well, and used Newton, and then we will continue to support it and add more features to it. For example, physics-based checking, collision checking. So it's basically an alternative to GMR, and we definitely took a lot of inspiration from it, and we'll continue to develop it.
Amazing. Here's a nice question here coming from LinkedIn, Farshad. is there any framework considered planned for online fine-tuning?
We're exploring that.
Okay, there you go. Enough said. But thanks for that comment coming in from LinkedIn. So many great comments and questions. We're just about out of time. Let me ask you all something. Actually, I'm gonna circle back to you. I'm gonna go over some news slides really quick because we've got some really cool stuff coming up. While I'm doing that, I want each of you to think about what you want your main takeaway to be from this past hour, because we covered a lot, and this is super exciting news. You can tell by the questions and the comments that people are very excited about this as well and are already digging in. So think about what you'd want to be the main takeaway if you had to tell in one sentence, and I'll come back to you in 1 second. In the meantime, we do have some exciting stuff coming up. Very excited. Thank you. Big thank you to Samantha from our team for helping to put together these slides for us. First up being, of course, what we talked about today. So if you're interested in learning more about Sonic after hearing from our wonderful experts here, you can scan the QR code and dive into the GitHub and other resources we've got. And I bet you many of you are taking a picture of this screen right now. So definitely keep in touch with the team by leveraging that issues area in the GitHub page. If you want to chat with other developers in the community, I strongly encourage you to join the Omniverse Discord server. We have an Isaac Lab study group actually that meets every Wednesday at 12:30 p.m. Pacific on the Discord server. So this will be a hobby. I bet you're going to talk about this today. If you're watching this live, it's Wednesday. So they're going to meet in about a half hour from now if you're watching live, if you want to join. There's no, you don't have to RSVP. You can just pop in the Discord server and go to the community room. Super exciting stuff. All right. This is really exciting too. In less than 2 weeks, Jensen's going to be speaking at GTC Taipei, part of Computex. And this QR code will bring you all the information about GTC Taipei. And don't worry if you cannot make it in person. It's a big trip. I'll be making the trip. So if anyone's going, let me know. We'd love to meet up with you. But if you can't make it, no problem, because you can catch the keynote globally via live stream from no matter where you are. This QR code will bring you to a page, and I think you can add this to your calendar and make it really easy to catch Jensen's latest news announcements. We're very excited about this one. Most of the team, I always mention this, most of the team does not know what Jensen's really going to cover in these keynotes because we all work in different areas. So we might know a little bit, but we're as surprised as many of you out there watching at the same time. So we always get our popcorn for these keynotes because it's very exciting for us as well. We hope you can make Taipei. Although if you can't, though, in addition to the keynote, all the sessions, as is the case with any GTC, is made available on on NVIDIA On Demand. So NVIDIA On Demand is our platform online, which has all our previous GTC sessions. So you can watch keynotes and sessions and lots of great panels. They're all there. They're usually added literally within days after any GTC finishes. There's going to be physical AI days at GTC Taipei. So we're going to bring what we did at San Jose to Taipei. Start planning your schedule with our curated session lineup in both English and in Chinese. That's pretty awesome. I'm hoping to pick up some new words when I'm over there. But this QR code will bring you all information about physical AI days. And as we mentioned a few minutes ago, ICRA, you can join us at another exciting event on the horizon. It's in Vienna, Austria. International Conference on Robotics and Automation is taking place from June 1st through June 5th, so overlapping with GTC Taipei a little bit there. If you're going, as Jan mentioned earlier, we can definitely have developers from our team that will be there. This link QR code will bring you to the full details on that. And oh my gosh, there's so many events. There's another event. We've got CVPR taking place in Colorado. We definitely hope to see you all there. For anyone in the United States, that's a little easier to get to than Taipei. June 3rd through 7th, that QR code will bring you there. There's also later on in the year, I don't have a slide for this, but we have SIGGRAPH coming up. It's always great things to look forward to. GTC Berlin, which we announced recently, is going to be in October. I'll be there as well. So looking forward to meeting a lot of the community developers there we work with day to day. And if you want to find out about the latest resources, this page is where everything is. The events is our calendar. You can add anything to your calendar, including this live streams like this one, our study groups, our office hours, keynotes, all on the events page there. Our forums is one place to go for support, but I think more and more we encourage people to use the GitHub issues page. but there are some technologies like Isaac Sim where we still have some developers that are helping people there on the forums. Discord server, like I said, is great if you're looking to kind of share a project or pick somebody's brain apart for your project, get some support from other developers in the community. Our Discord server is fantastic resource in that respect. In our community page, you can find out about some of our ambassadors. I mentioned Scott Dempsey from Worker Labs, was watching the stream earlier. You can read about him and others on that community page, as well as find out about other community resources and let us know if you want to be an ambassador. If you're an expert in one of our areas, we would love to feature you and celebrate your work and share your knowledge. Okay, you've all had a few minutes to kind of think about your parting words here. This hour has gone by very quick. And I think part of that is we had just some great presentation materials for all of you. The other part of it, I think we had some great questions and comments. Really exciting. I'm going to start with my amazing colleague, Raffaello, because this must really be exciting for you, because you get to kind of work with developers and the team on this stuff, but you kind of you're like the community in a lot of respects. So some of this is kind of news for you as well, right?
Well, thank you to say that. Yes, well, there are many community things, and also first for all, before because this live is going long, I want to say thank you for Jan, Zenji, and Sharon for this amazing presentation for Sonic. That was amazing. And speaking about community event, yes, we have many community events coming. Also, if you are working, if all people are writing on the chat, please join on our Discord and I will be happy also to reply. And for the coming event, I will be to the Roscon. These are the other events that
Great.
will be in Toronto. We didn't but you will know later. I hope I will be also in Berlin. And
amazing. That's where I'll see you then. That's why we're going to celebrate our 5-year anniversary in Berlin.
Yes, can be a nice idea.
And actually, so just to clarify, we have someone asking in the chat right now, are these recorded? Yes, if we did mention that early, if you missed it, all of our live streams are recorded. If you go to the NVIDIA Omniverse YouTube channel, just go to the live section. You'll see all of our previous live streams, including all of our previous Robotics Office Hours, which this is part of. So thanks for asking that question. So others will learn from that. Okay, Zen, what would you like to leave people with today?
Yeah, I would love to thank our community members who have checked out Sonic, who have left our star, who have tried it out. I think it's one of my mission as a researcher to help us out, help us the research community, and give back to the research community. And that's why we open source Sonic, and we will keep building and supporting this repository and giving more and more humanoid capabilities back to the community. I think humanoids is going to be a long journey. And it's not going to be 1 year, 2 years. But I firmly believe this is the embodiment that will work in our homes. And I feel like at NVIDIA here, we're building the infrastructure and the substrate for humanoids to be useful one day. And I just love the community, and I hope we'll be of help. And I will love to communicate and talk and discuss more with the community of what should we do next and what we can learn from each other. Thank you.
I love that. And actually, that's a really important point that I don't think people really fully realize, is that we do align our priorities based on feedback we're hearing from developers and startups and companies. So absolutely, let us know what's really important to you in your work. And we can take that with everybody else's and try to make sure we can help as many people as possible, as quickly as possible. But I love the fact that this team is so engaged also on the GitHub page. So you've heard it multiple times this live stream. So if you're having issues, definitely go there. But my bet is that a lot of questions are taken care of in the great documentation that the team has put together, and the demo and the web experience. So I think that's really helpful.
Also, we're curious about auto train as well. Many questions related to auto train on GPUs.
Yeah.
And use it, yes, in different type of robots.
Yeah. Okay, Jan, you kicked this whole thing off today and have been very helpful in kind of giving us a really high-level overview on Sonic. So I'm really curious what you want the takeaway to be today.
Yeah, firstly, thank you all for joining us today, and thanks all our amazing NVIDIA colleagues who make all those things happen together. And also, as Zhengyi mentioned, we open source all those things. We also welcome your feedbacks, and also we welcome your contributions as well. So all the things we mentioned, like Sonic, the ISAC Lab, the SOMA, the retargeter, all those repos, you can access that. You can also submit your commit, and we welcome all those contributions as well. And I also firmly believe that physical AI is an era that's the best timing for all of us to enter. And also, let's innovate and build together. I believe the community power will be very helpful for us to all accelerate towards the new physical AI world that we will all enjoy.
Oh, that's really awesome. So inspiring. No pressure, Shanwan, but you have the last word here. Take it away.
All right, cool. Yeah, thanks, everyone. Yeah, and I think Zeng and Yan already covered most of the things I want to mention. So I just leave a quick last one. It's like, I think everyone, if you have an interest, go try out our repo, go try out our deploy and training, everything. Leave your question in your GitHub, and also read our document. We spent a long time to make it, try to make it sufficient enough for you guys to try everything you want. So do read it and try it out, and leave your question in the GitHub issue. We will try to cover all. Yeah, thank you guys, and thanks for today's event. It's amazing.
Well, thank to each of you, and thank you everyone watching, whether you're watching live or watch as a replay. I hope this has been valuable. Don't forget to like the video, subscribe to the channel if it's very helpful to you. Reply in the comments. We'll keep an eye. But jump on over to the GitHub, jump over to the Discord, and we'll see you all there. Thank you all, everybody, today. It's been great.
Thank you all so
Thanks,
much.
Agmar. Thanks,
Bye-bye.
everybody.
Have a good one.
Bye.